Welcome to the Tech League podcast. Hello and welcome everyone to the Tech League podcast. I'm joined today by my usual co-host Krisztian Fischer, and we have a guest with us today, Mr. Xavier Torres.
Hello.
Xavier. Yeah. Usual housekeeping. We have an email, techleaguepodcast@gmail.com. Get in touch with us. If you want us to read your email, then send it to that email address. YouTube. I just said YouTube, Tech League Podcast, Spotify, Tech League, Apple Podcasts, Tech League. And then if we're not on a podcast provider that you want us to be on, email us at the email I said before, techleaguepodcasts@gmail.com, and let us know and we'll get ourselves sorted on that. That is the housekeeping. We can start. We'll introduce Xavi. Hello, thank you for joining us today. You are a long-time colleague of ours, business partner, and your background is much more more aligned with mine, infrastructure and operations, but more recently, very deep diving into Kubernetes and observability. Do you want to give us a quick overview of you and your background?
Yeah, sure. Happy to be here with you guys. As you said, mostly have been on the infra side of things during my career. I started as what you used to call system administrator, when you had a few physical servers on your charge, and you had to take care of things like networking, for example. I also been acting as a network administrator in the past. And then it makes me smile when you said recently I've been more on the Kubernetes side, because recently for us, like the whole career for many people right now, we have been at Kubernetes at least for 10 years now. But if you are in the info side of things nowadays, you probably will encounter Kubernetes for sure. It's what it's become the standard for hosting and running workloads in the industry.
And doing observability as well recently, right?
Yeah. That came kind of like related to Kubernetes, of course, because when you don't have any more tens of processes to monitor, but hundreds or thousands distributed across many regions and servers, then you need tooling for that. And I think observability has always been neat, but with the Kubernetes, it's almost a must. Otherwise, it's impossible to keep control of what's happening.
Nice. Thank you. We were working together when Kubernetes first came out. We were doing containers before that. And then we were on the bandwagon straight away as Kubernetes came out. So you're right. It's probably 10 years. I'm thinking around 2015. It was maybe around there. Anyway, cool. Yeah. So as you probably already guessed, listeners, today we're going to be talking about Kubernetes, more of a general and a bit of a deep dive with Xavi, as we have Xavi on the call. So if you were going to give a quick overview of what Kubernetes is, how would you describe it? I know how I would describe it. How would you describe it?
Yeah. The main purpose of Kubernetes is orchestrating containers. You have a bunch of containers you want to run, and instead of manually deciding where you're going to start and in which machine, that can be a physical machine or virtual machine, you just give the image URL to an API, and that API takes care of distributing the load.
Well, that was the hope, but then we ended up with like massive YAML files and other things on top of it.
Exactly. The problem with that is that, well, you have the containers running, but now you have to take care of how to route the requests, those containers in a dynamic way, because they are probably moving around if there are problems or performance issues. And that is where Kubernetes come to the rescue, I would say, but maybe got a bit over-engineered on the way. I remember we have run frameworks that really dealt with just the Docker problem, the container problem, like Mesos. And in those days, then you had to engineer yourself. How would you do the routing, and how would you solve the problem of all this pod is moving from this host to this other host? It is changing address, probably IP address. And then how do you do so the traffic is kept routed to that particular instance, right? And Kubernetes promised to solve that in a automatic and transparent way, but it comes with a lot of complexity.
So like, that's a good description. To me, it's a container orchestration framework / operating system-ish way of thinking about things. So it is just like an API with API definitions, and then that provisions a bunch of underlying magic that gets things running. So like there's the concept of pods, which was a new thing for Kubernetes, right? And I like that idea, the idea of a shared namespace with multiple containers all defined as one pod, and then you have shared namespace. What else is shared? I'm not exactly sure what's shared in a pod.
Well, you are running on the same process namespace, on the same networking, and you are sharing, well, because it's a container, you're sharing the kernel with the host machine, right? So ideally, you can have inter-process communication without having to leave the pod.
Yeah. That was, for me, it was the shared networks namespace. It was super cool. I remember I created a tool, because like something you can do with Kubernetes that I really like is you can add containers to a pod spec. And so if you're missing something, like you want to do some network debugging or something, you can create an image that has nmap and ping and all that sort of stuff in it. And then you can add that as a container within the pod spec and then exec into that pod container and use those tools within the namespace of the pod. So I really like that. And then on top of that, so you have the pod, which is the workload specification kind of thing. This is like, these are the containers I want. These are their labels. This is the amount of resources they should take. And then on top of that, you have the concept of a service. And that's what internal load balancing kind of deal.
Yeah, exactly. That provides an unique endpoint to communicate with all the instances of your service. So, well, now we are starting to encounter one of the other problems with Kubernetes, which is name overload. Because you were talking about sharing the network namespace in a pod, but of course, namespace, it's an object on itself in Kubernetes. That's something else. And now we're also overloading. So let's say microservice is like the process that you want to run, and that's probably listening for requests on the network. And then service is the Kubernetes abstraction that takes care of assigning DNS name / IP address that you can use to communicate with a bunch of microservices that are performing the same logical function.
And it does another thing as well, which is it works as service discovery as well, using DNS.
So if you get assigned a
that's
DNS
another
name,
overload of the name of the service name, right? So you get sorry, go on. You were saying about DNS names.
You get assigned a DNS name that you know beforehand how it's going to look. So in theory, any other service, microservice that's running on the cluster is able to communicate with you without having to beforehand communicate.
So it's service discovery within one cluster. It's not multi-cluster. It's just within that one cluster. We can get into more complex configurations later. So we have a pod, we have a service, and a pod can have n number of containers within it. And then we have a service, which is like internal service discovery, load balancer, DNS kind of internally to the cluster. And then there's the concept of ingresses. And you were saying to me the other day, ingresses are going to be depreciated in favor of gateways. But for now, we can talk about ingresses. And to me, that's poking a hole into the cluster towards the service.
Yeah. I mean, ingress is just a logical representation of the fact that you need, at some point, you need a reverse proxy, which is a process that is listening on the outside, gets the requests, and then utilizing the data on those requests. And that can be done at different levels. It can be by IP, by port, by path, hostname. It routes to the corresponding service as in Kubernetes object. So it's even a layer. Like you have the pods, then they have the service that unifies the endpoint for those pods, and then you can add on top of it, you can add an ingress or a listener now. That's an implementation of this reverse proxy configuration that you need route the traffic into the cluster.
And the thing about ingresses is you can choose how to implement that. There's no real default way. I think the default way is like Nginx reverse proxy. That's how they did it initially. But like the ones I'm doing at the moment, you specify an ingress object, and then I have a class that then provisions ALBs that point to, so AWS application load balance. So spins up and then points towards a service. So it's this is another thing about Kubernetes, it's super configurable. Anyway, so those are the three basic layers, I would say. Have we missed anything? I'm trying to get to people who don't understand or haven't encountered Kubernetes much. Are there some things that we're missing from a very basic level?
No, I think like from the logical standpoint, that's what it does. An easy way to understand this is that Kubernetes is an API server that gets requests in and does requests out. So you say, I want to schedule this container. the request, where you give the URL of the container, you give it to this control plane, and the control plane then goes and talks to the kubelet, which is the process that's running in each server, and gives them the instruction, okay, you and you and you need to spin up this thing that I got. And that the same goes for the services and the ingresses and all that. So it's kind of like a API bridge where you request what you want, and then that control plane figures out who will implement it.
You can think, I guess you could think of it as like Terraform or something. So you say to the API, I want it this way, and it just sorts it for you.
Yeah, it's in that way, it's the clarity.
Yeah. Cool. So that's an overview of the basics of Kubernetes for those who haven't heard anything. Krisztian, do you have any questions so far? You've done quite a bit of Kubernetes. You must understand this so far.
I understand these concepts. I wanted to ask Xavier, like, what other services does Kubernetes provide? Is it just running containers, or out of the box, what else do we get with it? So I'm in the role of the application developer. I created my container. I want to deploy it, and I originally, I understood you have a YAML file where you describe what the pod is, what the services are, what are the containers within the pod, and what ingress do I want, and then I give it to a magical API and it makes it happen. In my personal experience, we have diverted from that quite much, and I'd like to understand what's behind the scenes, because from an application developer's point of view now, we're always talking in every company about customize and kube control and Argo CD, and Istio and all these extra fluff that I have to work with. Could you explain what's part of the basic Kubernetes offering and what is on top and what problems are they solving?
Yeah, I mean, you touched on a subject that I think it's very interesting. Kubernetes, what we call the Kubernetes zoo. All the components that you have to bring with you apart from Kubernetes to make a real life Kubernetes. But we will get onto that later, I guess. I mean, off the top of my head, of course, Kubernetes is changing all the time, but what we have talked about is what vanilla Kubernetes provides. We could talk about persistent storage as well. Like there is built-in support for the volumes. And then the logical idea is that you have a volume that you can connect to a certain pod. And if that pod moves across hosts, the volume will follow. And that gives you a way of having persistent storage across tributes. I personally don't think it's a very good idea. I mean, of course, there are applications that must have that, but I think Kubernetes was originally thought of a platform for running ephemeral or
stateless.
What do you call it? Stateless workloads. But yeah, there is a support for the volumes as well. There is also ways of pinning containers to particular machines. Then you can take advantage of their local storage, but then all those are variations of the same thing. But vanilla, process, storage, memory, and network. That's what it provides.
And secret management as well, right? Because containers need secrets.
Add-on. There's a secret object, right? So you can create like opaque secrets and stuff within, but the syncing of secrets is not vanilla.
No. I mean, I think secrets, you can see it as a particular case of configuration management. And I was forgetting about that. Like of the box, you get what's called config maps, and then secrets are seen as a different kind of object. But I think that's just implementation leakage. And essentially, it's an object where you can store information that can be accessed by the workloads that you.
There are a few other things we haven't gone over that are included, I think, by default. There's deployments, which is like a grouping of different things together. It's like, so you want an ingress and I don't think ingress is part of a deployment, but like a pod, certain amount, different pods and certain services can be grouped into a deployment, and then a deployment can be deleted or updated as one, right? And then there's also daemon sets. There's a few other objects, but they're more specialized for daemon sets. Is like you have one on every host, right?
Yeah, those are more sort of a infrastructure for the infrastructure, right? And you do things like collecting logs and metrics or any other process that you need present in every host. And usually it doesn't have to do with any of the business workloads that you are running. It's more of a meta loads that you would use to handle your workloads and also your cluster. And then you need, with a daemon set, you automatically create a deployment that will be run on every machine.
Did that answer your question?
Yes, more or less. You mentioned on some of the topics, as an application developer, let's say I'm interested in how do I see my logs? How do I send metrics and all these extra? But these are not natively part of the Kubernetes solution. These are always custom solutions that I have to add to the cluster, right?
If you log to stand it out, then there's a way of grabbing those logs through the Kubernetes API, but there's no way of aggregating and sending them to something. Correct me if I'm wrong.
No, I mean, you can get to the logs either. Like when you were mentioning outputting a standard output, but in the Kubernetes context, that just means that your logs are going to a file on the host machine. And then you can get there. And then there is some support. For example, there is the standard command line tool, which is kubectl, which is for interacting with the API. And then there is some smart tooling that allows you to output, for example, the logs of all the pods in a deployment. And then it's color code, so you can see which line comes from what pod. But those tools don't scale too much. It's good for quick debugging and if you don't have the infrastructure yet for real observability, but they don't scale too well because, again, like the terminal was a tool that was used when you had one process in one server and you could manage that. At the moment you're running tens or hundreds of instances, you need smarter tooling for handling.
So in your opinion, what's a minimum set of Kubernetes objects or setup that satisfies a minimum requirement for a service? And that includes running the service. If host dies, then it automatically goes moves to another host, autoscaling maybe, and logging and metrics. If I consider this, and of course all the above of Ingress and HTTP or SSL termination.
Some way of syncing secrets from a secret store. But maybe we can roll back a little bit. In your opinion, say I'm a new startup, we have money, the development teams, they want Kubernetes, and I have access to a cloud account or on-prem. Which one would you go with? What's the easiest, best way to start with a Kubernetes?
That depends a bit. It's a bit of a taste question. I would definitely go with cloud nowadays. I've built Kubernetes clusters on top of hardware, and it's something you can do, but then that really adds a big overhead on your team. Because then all of a sudden,
explain why? Why is it so hard?
All of a sudden, you have to deal not only with the Kubernetes and associated services that we will talk in a moment, complexity, but also everything that's under Kubernetes. You have a bunch, of course, of hardware, but also the operating system on top of Kubernetes, which complicate upgrades. Then you have to deal with the network architecture as well, because it's very flexible, but that means that there is a lot of choices. And then you have the complexity intertwined of the physical layer of the network, of your routing. And then on top of that, you have to add all the Kubernetes networking, and API allocation and all that. So I would definitely go with cloud. Which cloud? I mean, I think at this point is more of a taste question, because I think all the main providers are very, very mature and offer very good support for Kubernetes. Google has an advantage since it's the company created Kubernetes. I haven't worked with Google Kubernetes for a long time, but I remember it being very little overhead between vanilla Kubernetes and Google Kubernetes, because they use the same naming, they use same abstraction. So it made it easy if you knew Kubernetes from the beginning. But of course, AWS and now Azure are very mature platforms that offer a lot of services around Kubernetes as well.
Do you know if Google, for example, or Azure, they do like auto scaling of nodes in the compute workloads or not? Do you know if they do that?
Again, I haven't worked with GCP in a few years now, so I'm hesitant to say any, but I'm sure that all of these providers offer scaling. Kubernetes have several dimensions. There is horizontal scaling, vertical scaling. You can scale pools of hosts. You can scale the pods. So there are several dimensions to this problem. And again, that's one of the things that if you are not running the cluster yourself, you can take most of them out of the way and focus on pod scaling, which is what is interesting for the business application.
But the reason I ask is because I've been doing EKS auto mode. EKS is the Amazon managed Kubernetes. I'm doing auto mode. And what that does is it will automatically provision the compute resources, the EC2 machines that run, and automatically put them in the Kubernetes cluster. I don't have to say, I want 5 nodes. I just have as many nodes as I need. But that is scaling the cluster. You're correct. And that was the question I was going to ask. We can get into pod auto scaling and stuff in a bit. But Okay, so this is kind of harkens back to last week's episode about DC versus cloud. Like if you're going to run a Kubernetes cluster and even if you want one on hardware, you need a whole team just for running the Kubernetes cluster. That's our experience, right? And that team could have been maybe better used in sorting all of these extras like observability, secrets management, ingress automation, deployment automation, autoscaling, all that kind of stuff, right? So would you agree with me that it's almost never worth running your own on-prem Kubernetes cluster?
Yeah, mostly if you are starting from the beginning, never. If you run it yourself, you have to have a very good reason, or you are in an organization that has a great infrastructure team, but infrastructure as in physical infrastructure team, good networking, good hardware.
Not to blow our own horn, but we've done it, right?
Yeah, yes, we
We've
did.
done it.
It was also we came from a time when everyone was running their own servers and their own network, so it seemed only natural to do that.
This is because,
I
like
think-
we were saying, it was 10 years ago. It was when Kubernetes just came out. So we started using it on our own hardware.
Yes, and it would be very difficult to try to justify this for a small, medium company. Oh yeah, just give me these 5 guys 100% of the time, and I will have a bunch of servers to run your workloads. When you can do that for, I don't know, a few bucks a month in a small, medium company.
So if you're running Kubernetes in the cloud, how does that differ from running it in the data center? What tasks are you not doing in the cloud that you used to do in the data center?
The main difference, I think, and the thing that gives you more peace of mind as an infra person is that the control plane that we were talking about is a set of servers that is not visible from the Kubernetes cluster, but are running the API that runs everything else. And that is also distributed. It's usually, it's recommended to running at least 3 servers. And the underlying storage for that API and for the state of the whole cluster is also distributed. Again, I haven't done that in a few years, so I'm hesitant to name any concrete algorithm or anything like that. In our time, we were doing Raft algorithm and distributed database. And those are complex systems that need 100% availability because everything depends on them, require very meticulous planning for upgrades and backups and so on. And that's the first thing that you can get out of the way with cloud. They offer you the state. You don't even see the servers. They give you the API address, and that's all you need to care about. So that is the main selling point, I would say. And then, of course, they offer you an easy way of handling the host pools where you will be running your workload. So, for example, nowadays you might need nodes with a GPU for some ML workloads or whatnot, but you will do those just sporadically. So if you were managing your own cluster, then you need to buy a host with a GPU, which is expensive, and then you need to maintain the operating system, the drivers. If you are using cloud, you can just have a pool that scales to 0, and then the day that you have a workload that needs the GPU, they automatically provide one, run your workload, and then that scales back to 0 again, much cheaper and much more hassle-free. So that would be the other advantage. You don't need to manage your pools of hosts. You get offered virtual machines on demand for your workload.
So it sounds like they do everything for us. So why do I need an infra team then to do anything in the cloud?
Yeah, exactly. So it's very easy to sell just because of that. I mean, I can understand that a manager that maybe is not very, very knowledgeable on the details is like, has exactly your same thoughts. But then the problem that we have been getting to is that Kubernetes by itself offers these basic primitives to run workloads onto them on the network and whatnot, but doesn't offer any tooling for deployment and configuration. The management can be done through config maps. That's how would you create those config maps. And also it's declarative, as we were saying. So it's using YAML famously or infamously for creating objects in the API, but that you quickly realize when you have a big deployment that it doesn't scale very well to keep maintaining YAMLs that need to be kind of similar but different in different places and versions and whatnot. And then there is all this host of tooling around the Kubernetes cluster to make it practical. So if you want, we can talk about that. There is a whole host of utilities and services that you need to.
Well, we can start by, my question would be, okay, and I like to do scenarios, as people who've been listening probably know. Like, okay, so you've got a cloud-based Kubernetes setup. You have a development team that wants to use Kubernetes. What are the bare minimum things you would add to a vanilla to get it ready for a team?
Yes. So I think one of the things that you need, maybe not the first stage, but the second is observability, because as we were saying, it quickly grows out of control the number of logs and metrics that you are generating. For that, nowadays, there are very good tools that allow you to configure it very quickly. All of them are based on the principle that you run what they call an agent, which is yet another process, every host. So you would use the daemon set object, exactly. And then those are privileged containers that have access to the hardware or to the host operating system, rather. So they can read logs from all the other pods, they can read metrics from all the other pods, and so on. So they aggregate all those metrics and logs and traces and whatnot, and then they send them through the network to a central repository where you usually have a UI, and then you can search, you can filter, you can do queries and whatnot. There are many examples. Grafana is one of the most popular. Datadog, of course, Elastic, there are many more nowadays.
Do I need an agent on my pods? Can't I just directly send the data? What's the difference there?
So for logs and metrics, there is standard ways of delivering those, and then you don't need to change your code, so to speak. So as Toby was saying, you can merely output your logs to a standard output. Essentially, we'll get in a file in the host, and then the agent, the observability tool agent, will collect those from that file. That is worth to say that depending on the language that you're using, maybe standard output is not the best because the standard library might be blocking, and then you might pay a performance price. So it depends a bit on the language that you're using. You can just log directly to file. Metrics, the standard way used to be to create a Prometheus-like path on your application. So you expose your metrics in a Prometheus format in /metrics usually, and then the agent will periodically scrape that file and then send them the content to this central repository where it's going to get processed by a time series data.
So metric is typically a pull method, and logs are push. I just write it down to my local file system, and it will be picked up by an agent that is running within the same pod, and then its responsibility is to
same pod. Same host.
So it's running on the same host, and sends it wherever it needs to be, and my process is not blocked by this delivery.
Exactly. From the point of view of the service, of the process of the microservice, yes. Then metrics, once they are gathered by the agent, there are different ways. You could have a Prometheus server, but that's kind of getting deprecated, I would say. I mean, network is getting good enough that you just can send them directly. And then there is an interesting trend now. Traces. Traditionally, what you had to change your code. You had to import the SDK or the library of the whatever tool you're using. And then there was support there is support for some automation. So if you're running a microservice based on Node.js Express, you'll get some out-of-the-box traces just by importing that SDK. You will get latency on every method and whatnot. And then you could program your own traces, say, okay, from this line to this line, measure the time and give it to me or whatnot. But that is changing now, and they are finding ways of not having to change your code either for traces, because that's always what had been the negative part of traces, that, okay, yeah, we can have traces, which is going to help us to debug and whatnot, but our developers need to rebuild the application and keep track of yet another dependency and so on. Nowadays, there is what they call the zero dependency traces. So you essentially wrap your application in another process. I'm not very with the details in this, but essentially, instead of importing an SDK, you wrap your application, and that wrapper captures the points where traces are generated. And then now there is yet another way of gathering information from your applications without having to change anything, which is profiling. So traditionally, profiling needed you to be in the same machine and have access to the kernel to see your function calls and all that. But now, thanks to Linux eBPF, you can profile. You can run and export your profiles without affecting performance, and in a way that you can package it and send it through the network as well. So it's almost like magic. But we were talking about what's the minimum necessary, and I would say at this point, if you are starting,
observability, yeah,
observability,
but not traces, not profiles, just logs and metrics, right?
Logs and metrics, I would say. And the logs is very easy. Just install the agent, we will get gathered. Metrics, it's nowadays standard in almost all languages. Generate a Prometheus endpoint on the agent we gather.
Okay, so that's on the runtime side. And then me as a user of a Kubernetes cluster, as a developer, you mentioned that we need some tooling to generate those complex YAMLs. What would be your recommendation there?
Well, we're still on the bare minimum stuff, right? So we need some way of templating YAMLs. Sounds like a horrible thing to me, but
the YAMLs have an interesting life. There are two sides to this. One is how you generate your YAMLs, and the other one is what do you do with them? Because we said that Kubernetes essentially is an API where you send your declarative requests or things need to happen. So when you start your first day at Kubernetes, you just run CLI tool, kubectl, point to the YAML file with the specification, and that works. You can do that in a pipeline later on when you start. Mainly if you are part of a team and you don't want people running kubectl each on their machine. So then you put that command on the pipeline, but that grows old very quickly as well, because then you're having essentially a deployment that it's not idempotent. It's a word.
Mm-hmm.
I mean, if two people are running more or less at the same time, but slightly different deployments, the one that comes last will win, and they might have conflicting changes and all that.
It breaks as soon as more than one person is working on the code base, I would say.
Well,
yes.
if the pipeline allows multiple updates. So
if
only one
parallel runs.
Yeah, exactly.
From different branches. So all this to say, what has become standard nowadays for the deployments in Kubernetes is what we call Argo CD, which essentially is a process that's running somewhere that monitors your YAMLs. Let's start with YAMLs. Monitor the YAMLs in your Git repository and monitors the API in Kubernetes for the current state and reconciles those in a smart way. And that usually you point to a certain branch or reference in your Git repo, so you know that one. So there is a correspondence one-to-one between a particular deployment and a reference in your Git repo.
But I still have to generate my YAML files for Argo CD to work, right?
Exactly. Then Argo CD definitely works with YAMLs, but again, you can imagine if you are working with microservices, and they are more or less the same kind of microservice, a Java application or Node.js, whatever, 90% of your manifests will look the same way between different microservices. And the problem is that those manifests nowadays carry a lot of metadata, they carry a lot of configuration, resources, whatnot. So the moment that you want to make a change across all your services, then you face a problem of synchronizing those manifests, making the change to all the manifests, but still you don't want them to diverge too much and so on. So there is several template solutions. Most popular are Flux, Customize, and Helm. They all are a bit different. They excel at some things and it's not so good at some other things. But essentially, I would say as an application developer in small projects, Customize, maybe it's the easiest to understand. It uses essentially composition to reuse base templates and then do some patching on top. While Flux and Helm are more of a packaging solution. Nowadays, for example, if you want to deploy your observability agents, at the end of the day, I mean, it's conceptually easy, but at the end of the day, there are many components that go into that. And some agents you want to run on all machines, but some others you don't. Then you have collectors that collect all that data and buffer it and transform it before you send it out, and so on. So they become pretty complex. And you can package all the complexity in a Helm template, for example. Essentially, it becomes Helm, it's all Grafana.
Mm-hmm.
And then all that complexity is hidden. But then you're just hiding that complexity inside the templates. So yeah, for starting out, I think Customize would be the best option. And Argo CD have support to read those natively. So you can write them in any of those systems. And then Argo CD is smart enough to render the final YAML from those.
Okay, so Argo CD does the magic as well. So it doesn't just expect a rendered YAML file, but it can also run the rendering process. Mm-hmm.
Okay, so let me summarize for listeners who maybe have a little lost, because it is a very steep learning curve, Kubernetes. And it's always the example I use when I say about curse of the expert, because once you've been in Kubernetes for a while, you just kind of natively understand the language. But for people who haven't used it a lot, it can be very daunting, all of these new words. So when you start up, you get a vanilla Kubernetes, but then you want to have some sort of observability. So you install some sort of agent that will collect logs, collect metrics, send them to somewhere where you can look at them. Then you want some way of, because you're specifying what you want to happen on the cluster in terms of workloads and whatnot in a YAML file, there's a lot of use cases where you want to template a lot of those into different ways. So you would use something like Customize or Helm or something, and that handles the rendering of those YAMLs. And then once the YAMLs are rendered, or in the case of Customize, if they haven't been rendered yet, you'd have a service called Argo CD, which is a different application which watches, say, a Git repository, pulls the YAML files and applies it to your cluster. So it keeps your cluster in sync with your Git repository. So that's where we're at now. So an application developer, they would write their application file, push it to an image repository, update their YAML file, and then Argo CD would sync everything so that it's good. Is that a good summary so far?
Very good.
And I have a question about because we only touched on the resources that are managed within Kubernetes, right? The compute part, but almost all applications also have state in the database or require some other external resources like an SMTP server or whatever AWS provides, or it could be any external service. If the deployment of my application is happening through these automated processes you just described, how can I synchronize the creation of those resources at the same time? So let's say I want to make sure that in my code, I have the database schema at the change at the same time when I want to release the application. So how can I schedule these processes? Because it sounded like as soon as I push to the repo or merge into the main branch, it will start deploying and the database might not be there yet. How do you solve these situations?
Yes, and that's a very good question, and it's part of the continuously grow of Kubernetes solutions and objects and whatnot. So traditionally, when people started using Kubernetes, then it became the hammer. When you how do you say?
All you have is a hammer, then everything looks like a nail.
Thank you. Yeah. So they became the hammer in that say. So people simply, okay, but then we schedule a Postgres with a volume, as we were talking about, and we will run it alongside our loads. That might work. Again, I think stateful applications and storage it's a problem waiting to happen, I think, running Kubernetes. And then, of course, you are faced with the same problems that you would have if you're running your database in a server, which is you still have to do updates, replications, backups, and all that. So now, with the advent of the cloud offerings, nowadays, almost everyone is. I'm talking of database because it's an easy example that you could apply to PubSub queues or whatever you want. Those solutions nowadays usually are also offered as a service in a cloud provider. So you just say, I want a Postgres database. They give you a URL, username, and password, and they manage the upgrades, backups, and whatnot. But again, then how you synchronize that? How you make those external resources visible from Kubernetes? My answer would be, unless you have a very specific need, you can just live with that. You know that the database is out there. You just are careful, like you did when you didn't have Kubernetes. But at some point, you might need some automation around that on very big deployments and whatnot. And then Kubernetes is flexible enough that allows you to define your own objects. They call CRDs, custom resource
definition.
Definition. Thank you. And as a part of that, you could define a database. But then, of course, you have to implement that. So there is a tool similar to, in a way, like Argo CD that's running alongside your cluster. There is a tool that's called Crossplane, for example, that allows you to, it even allows you, if you know how Terraform works, which is you a declarative file where you say, I want a database in AWS with this RAM and this, whatever. You run that and then essentially gets translated to an API call to AWS that creates a database. It's like that, but with all the Kubernetes advantage, which is you get two-way synchronization. You can create a Kubernetes object that wasn't in the API when you installed it. It's not a service, a deployment, or whatever. You define it yourself, and then Crossplane will take care of the implementation. If it's in Azure, it's in AWS. and we'll kind of translate that Kubernetes object into the appropriate API calls in your cloud provider to give you back that resource. And then, of course, as part of that, you could define liveness probes, readiness probes, and whatnot to be able to synchronize internally when the database is ready or when this process has happened, then I can do the next step.
So it's quite extendable, but I might need to implement these extra resources or nodes, or I might be able to find a solution for that, like Crossplane.
This is one of the problems, I think, of Kubernetes. It's one of the best things, and it's one of the problems, is it's so extensible and so open that people tend to overcomplicate. And that's always the same with everything. I've seen people overcomplicate Terraform, which is madness to me because that's super simple, but it's the same. And it's, maybe we can pivot a little bit into discussing the pitfalls of Kubernetes, because this to me is one of them. It
sounds like it's getting more and more complicated.
I mean, we started with vanilla. You can create a pod with some containers in it and run them with Ingress. And now we're talking about provisioning cloud resources using Kubernetes. It can explode in complexity. And then you start introducing multi-cluster or service meshes and stuff like this. Then it starts getting really, really complicated. And you end up having your whole Kubernetes team or your DevOps team or whatever it's called just bogged down in managing Kubernetes. And that's on the cloud. That's not including running the control plane and all of the underlying hardware. It's just managing Kubernetes. And now we've probably discussed this before, but to me, it feels more and more like the trend is to offload software complexity into the hardware/infrastructure layer, things like service mesh. And what are your opinions, Xavi, on the pitfalls of Kubernetes? What have you seen happen time and time again that probably shouldn't happen? This is where you need to be a bit opinionated.
Well, that's easy. As you were saying, the complexity is the main pitfall. It's so easy to start because it's so attractive. Like the database example, I think it's a very good one. It's so attractive to think, I can manage this external resource as yet another Kubernetes cluster. I just can add it to my manifest. Now it's going to be taken care of by Argo, and I can version. I can use all my fancy tools for manifests. But that's from the user point of view. On the background, that you all of a sudden have yet another service, Crossplane, with its own versions, with uptime, with shifting providers all the time because the cloud APIs change all the time, so you need to keep up. So that's why in the beginning I said, if you can afford or you have enough expertise in the team to run the database completely off the Kubernetes cluster and just have it as an external resource that you can connect and fetch data from and whatnot, do it, because otherwise you're adding more and more burden on your DevOps or the team. Complexity for sure is the main pitfall. And then this is not even mentioning that every time you add this kind of thing, you add more complexity to the deployment itself, because developers, in the beginning, you say, all you need is a YAML and I will take care of everything. But that quickly gets complicated because, yes, there is one YAML that's my application that I can put on mine. But usually what happens is that if the system was started by developers, there is a distribution of the manifests. So each application has its own manifest in their own repo, or they are creating like a specialized repo with the manifests for each application. If the system was started by an infra person, then usually there is a monorepo, central monorepo with all the manifests. And then the moment you start using tools like we were talking about Helm or customized or Flux to try to reuse code, that becomes complicated very quickly as well, because then change from one person can spread to all the manifests, and you can trigger, for example, a redeployment of all your applications and whatnot. And again, then the users, you promise the user simplicity, and you promise the users you just need to learn this very simple YAML syntax. But now, a few steps on the way, then all of a sudden they have to create YAMLs in different repos at different times, keep track of if Argo CD is synchronizing them or not, if Crossplane is running or not. And it creates a deployment much more complicated if you were using like a server and a Git push in a way. So yeah, that's a very common issue. And that's why you need to think very hard before you implement a new fancy tool that will simplify your deployments, because in the end it does.
Yeah. And I mean, I think about it. I was saying, I don't know, was I saying it on the last podcast or something? I still think about most of these scenarios as wiring, like with networking. you're wiring the things together. And it's like we're pushing all of the wiring into one YAML file. So it becomes incredibly complex and really hard to disentangle. So there's like a really massive mental overhead there. And then the other complexity thing is service meshes. Now, I don't know if people know this, they probably gathered it from the listening, but I have a pet peeve against service mesh. I think if you've got to the point where you need a service mesh, you're doing Kubernetes wrong. Xavier, can you explain what a service mesh is and why do you agree with me or disagree with me on that?
I don't have, luckily I would say, a lot of experience personally with service meshes, but essentially what you are facing is a problem where at some point you need to, or depending on your environment, you will need to, for once, route the traffic between your microservices and decide which microservice can talk to which microservice. On one side, on the other side, you want encryption on your communications and possibly authentication, service to service. And yeah, that's basically that. And then you need a central point to try to steer all this and also monitor it. As you can imagine, that's a very complex thing, not only to implement from the user perspective, but to implement at the technical level in the clusters. You need to introduce a lot of layers of abstraction. So that's one of the other things that will give you a lot of complexity, and you need to think very hard if you really need that or not. You really need encryption between services. But encryption nowadays, I think it's a must for sure. But do you really need to be able to central configure it, or you can get by with other systems that the developers can implement between themselves?
So to me, like if I can summarize again, the way I see a service mesh is the way we were talking about Crossplane, where you can define objects that will provision resources. This is more like a way of defining objects that control networking within clusters or multiple clusters and the connections between them. So it's software-defined networking, but in Kubernetes objects. That's basically it, right? There's no more than that.
To make it easy to visualize, it's like from the process perspective, you're telling it, if you want to talk to the database, talk to your local host at this particular host and don't worry about anything. Encryption, routing, anything. And then on the background, you have another process that's taking that request and doing all the stuff that needs to be done with encryption and routing and translation of addresses and whatnot. That again sounds very attractive for the developer because you're just talking to local host. But in practice, when there is a problem with that, the developer doesn't know what's happening in the background. They are not going to be able to help you. And you as an infra person know how it's supposed to work, but you don't know what they are doing for that not to be working.
It's a bit of a black box, right? This is what I was saying about pushing the complexity of software to the infrastructure layer.
My problem with this service mesh approach is that you're hiding the usually very nice address of the services. Usually you have a domain name, myservice.mycompany.com. Like, and maybe it's an internal address, but it's easy to reason about that. And then I can move the service behind the scenes without you having to do anything. But if one service assumes that the other service is within Kubernetes, then you have no choice. You have to stick with that. And then you're confined to that ecosystem. If I want to move my service into a Lambda, for instance,
the service mesh supports that. And I've seen places where the service mesh extends out from Kubernetes into the data center, into clouds. It becomes a complete madness. So like you can address something in Lambda as if it's within the Kubernetes cluster, and it's horrible.
It sounds like to me, just to translate to software engineering terms, it sounds like we have global variables everywhere, and everybody tries to use the global variables, and it's magically propagating between the services, right? I know it's not exactly a one-on-one, but it's the same on the networking layer. I prefer personally more explicit addressing of services. So it's not magic behind it. I know I've resolved the domain, that's the IP, and I'm going to talk to that. And then I also don't have to know what technology they are using or that they have service mesh or not. Or I can talk to a third party because you can't extend the service mesh to a third party either, right? So then I have one way of talking to other services.
You would think there isn't, but I'm sure that there's some way around that.
Well, I mean, I think sometimes these extra abstractions comes from the fact that maybe the person that came up with them didn't really understood the existing abstractions, because at the end of the day is what you were saying, like DNS took care of that already. You can assign a name to service and then you can move it around because that results into address and so on.
It's a solved problem.
Yeah. And then adding more, adding more abstractions on top of that to be able to implement things on the infra side, as Toby was saying. I don't think that solves it. I was having a conversation with a colleague recently about the new people that's accessing now to the jobs as junior developers don't have per se a need of learning anything about networking, very little about operating systems, because they're using Kubernetes and containers. That, of course, broadens the workforce, because now you know JavaScript, you can do websites, you don't need to know how to host a server and how to put it out in the internet and the routing and all that. But at the same time, it creates these voids where no one knows what's happening because the developer doesn't know anymore what an IP address is or what a route is. And the infra person doesn't know anymore how JavaScript come to the conclusion that needs to talk to this address, not this other address. So to me, it seems like what we gain in one side, it's like the conservation of energy. What you gain in one side, you are losing it. Exactly. That's my impression.
This made me think, because you mentioned already so many technologies that you have to run on your working nodes of Kubernetes. Because you mentioned the agent that collects the logs, you mentioned Crossplane, you mentioned Argo CD, which I assume is also running on Kubernetes itself, typically. Now you mentioned the service mesh. So what's a healthy ratio between all these resources that have to run on the cluster versus your actual workload? Because to me, it sounds like it's already consuming a lot of resources that you have to pay for. So this might only make sense at a quite high scale of actual payloads on the cluster. So what's the good ratio there? Like how many
I can give you a good example. Like recently when I set up EKS, I did external DNS for syncing DNS records. I did Ingress controller, secrets syncing, and observability with Grafana Alloy. And I was running 22 pods and no workloads.
Mm-hmm.
So like it feels like you're just burning money. But once you're up to like 22 pods of workloads, maybe then it's 50-50, right?
But that's still a huge number for infrastructure, right? That's half.
And that's basics. There's no crossplane, there's no service mesh, nothing. That's just basics.
So half of your money goes into the infrastructure. So we have to be mindful of at what scale we introduce these technologies, right?
I mean, yeah, because I remember I look at the bill and I'm like, oh God, what am I doing? But they asked for it and it will scale out. Like back to Krisztian's original question, what point do you think, Xavier, is a good point to start with Kubernetes? Like what level of workloads? Because I'm just giving an example. That's 22 pods we're running with nothing.
Yeah, I mean, I don't think there is a definitive answer, like this many services, this many people. But I think it depends a lot on the architecture, I guess, of the software you're running. If you are really a microservice-based architecture, there might be benefits to running Kubernetes very early on because of the resilience it gives you of running several instances across many hosts and even regions and whatnot. But at the same time, and you have talked about this in other episodes, when does microservice architecture start to be worth it? Because I think that probably 80% of services out there, I don't know, I'm just making up the number, but many services that have a microservice architecture would be just fine if they were running in the monoliths or in a much less distributed way. And then Kubernetes loses a bit of the appeal because if you're running, 5 processes, then you might as well running them in a couple of servers and distribute them in another much simpler way.
So maybe you could use an architecture in that scenario where you just run the workloads all the time because it's still cheaper than running Kubernetes to run the workloads and do dynamic routing, like a health-based routing to the instances. Right?
I was going to say something we haven't covered. Maybe we can cover it now. If your workloads scale up and down a lot, or if you're doing it properly and you're using stateless, you could use something like Carpenter to auto provision nodes, do spot instance provisioning. That's a good use case, I would say, right? So like there's something Kubernetes can do is auto scaling. Or do you need an extra tool for that, like Carpenter?
Well,
how would you do it? Yeah.
As we were saying, you can scale to different things. You can scale the pods, and you can do, of course, horizontal auto scaling, which is or horizontal scaling, which is amount of pods. Because if you design your application correctly, and it's truly stateless, you will be able to elastically decide how many instances of that application you're running, and that won't affect the end user.
So Carpenter, my bad, Carpenter's the node scaler, right?
Carpenter, exactly. It takes metrics from the cluster and then instructs the underlying API for the host creation to increase or decrease the number of hosts.
I think that's what EK's auto mode is using behind the scenes to scale up and down nodes.
So Kubernetes only has the capability of scaling the number of pods by default. I can tell it if the load increases, you can add more pods of the same type.
Does it
but
have,
it cannot
but
automatically.
can it do that by default is the first question there, I guess.
Yeah, I think so.
Can it?
Yes, there is.
That's my understanding, right?
Now, I mean, there are some things that have become so commoditized, so to speak, that I'm hesitant now, but I think horizontal pod autoscaler is native from Kubernetes from a few versions back.
And Carpenter that you mentioned, Toby, that is adding more hardware, so to speak, more nodes that can run pods. And these are two different dimensions. Okay, thank you.
Yes, and that becomes possible when there is a semi-standardized way of creating. Natively, Kubernetes has very support to add and remove hosts. So you can, once you have deployed the kubelet, you can, with one request, add a host or remove it from the cluster, which makes it available for workloads or not, with all the details and eviction and all that. But it doesn't have an automatic way of doing it. So things like Carpenter is like the glue between gathering metrics from the cluster and applying the right decisions to use that capability of adding or removing hosts, which becomes very complex as well, because if you work with Carpenter, it's not only add hosts, remove hosts, but which metric, which thresholds, and then apply that logic to decide which kind of host you need, because depending on you're getting out of memory or out of CPU or even GPU, you will need one kind of host or not. And then optimize that for cost is another layer on top of that. But that is also, as I understand it, being commoditized by the providers. And as Toby was saying, like the new offerings of Kubernetes offer that out of the box as well.
Okay, so that's not another tool I have to run on my cluster.
Well, no, but I'm wondering where this will end up, because there has been this trend where there is a common problem to solve in Kubernetes, for example, Argo CD with the deployments, or the Carpenter with the scaling of the hosts. Then there is some attempts to solve that problem. Usually, one open source project becomes the standard on that problem area, and then since it is open source and it becomes the standard, the providers add it to their offering. Not always in a transparent way. Some might say we run, for example, Argo for you. Some others will brand it some other way and even fork it and slightly modify it and say, if you put your manifests here, it will magically get deployed, but not tell you, not give you access to Argo.
I just read the news that AWS added Argo CD to the standard EKS offering.
This is one of the good things about Kubernetes, because I sent that K gateway the other day, because they're creating this, they're moving from Ingress objects to gateway objects with like the ability to define APIs and stuff. But also then there's projects coming out that will manage those gateways, and they do things like MCP server gateways or like LLM proxy gateways. So it's kind of feels a bit like JavaScript in a way. There's a lot of people who are very passionate about solving problems with it. So I like that about Kubernetes, and it usually is very quick to solve new problems. But the downside of that is it's easy to make it incredibly complex.
It sounds like you can build a Frankenstein very easily if you don't know what you're doing, and you just listening to the hypes and keep adding new technologies to it, and then you end up having more workload for the infra than the actual workload you're running, and that defeats the whole purpose.
I mean, I've had this scenario where a security team says we need MTLS service mesh in Kubernetes. And I'm like, no, you don't say that. You say what the problem is. What do you need us to solve? But they've already decided that because this is the trend and they want it done this way. And it just adds more and more complexity. And then we go down these massive rabbit holes. Anyway, I'm ranting a little. I don't want to rant too much on this one.
Let me ask a provocative question. Me as a software developer, when do I have to stop caring about all this infra stuff that you mentioned? Because all I want to do is I create my, let's say, okay, with creating a container. I understand that because I'm a dumb. That's the limit of what I want to understand. I have a container and I can describe how many CPUs I expect the container to run on and how much memory I need and what is the minimum number that I want and the maximum. Like, why do I need to care about all these charts and YAMLs? To me, in my head, the real requirements that I have to specify are minimal. Do you see a trend where I could actually utilize all this Kubernetes magic and autoscale and whatever without having to deal with these complexities that you mentioned, with the deployment and the definition and the templating and meshes and carpenters and all that? Like, where do I have to stop caring about this?
I think that it starts to be a trend to look for alternatives to Kubernetes for the scenarios that we were discussing, where you either don't have a terribly high number of microservices by design, or you are simply a small company or a small project. So I think there might be a future where we come up with a new abstraction. I don't know. I mean, I think like containers have proven to be the correct abstraction, right? We barely remember now, but there was all these problems with the shared libraries and the dependencies and all that Docker solved. And that has proven to be a solution that lives on and that's been adopted in multiple ways. And now it's Kubernetes, but we have also seen other solutions based on containers. And I think this is going to continue, and it's going to come to the point where there will be simpler ways of deploying simpler applications. We in the industry, I think everyone is aware that Kubernetes, it's not the universal tool that was promised, really. It's only worth from a certain level of complexity. So hopefully
to me, from what you guys said, like, to me, the picture is quite clear that this technology should be used by the cloud providers, not by every single company we work with. Because it sounds like all companies solve exactly the same problem over and over again. How do I talk to another service? How do I do this metrics? How do I do the logs? How do I do the secrets? It sounds like to me that we're just repeating the same or solving the same problem over and over again in each company that is not really a cloud provider.
Well, I know companies that are making a lot of money just providing managed Kubernetes. Like,
there's always that argument to make money.
No, but I mean, because it is the same over and over again, and the consensus over time, it will standardize on things like Argo, for example, or metrics endpoint for metrics and stuff like this. I think it's too low level of abstraction level still. Me personally, I think we should be able to just say, I have this container, I want to run it here, it connects to this, run it for me. That's it. And I think we're getting closer to that, hopefully.
So you expect a consolidation once like the best practices are more clear to the industry, than maybe a standardization process that will be picked up by the cloud providers? Or
I mean, there was Cloud Run. There's Cloud Run, which is container as a service, right? That's a really nice abstraction level, I think. AWS tried it with App Runner, but it ended up being a bit too complicated, I think, personally. To me, Kubernetes was really good at the main thing it was good at, because we didn't get into the background, but it came from Google. It was their Borg OS that they ran in their data centers, turned into a tool that everyone can use. It's very good at like having a big fleet of workload machines, compute machines, and being able to just install it on everything, and then developers can just deploy stuff onto that, right? And then you can pull a server out and it will rebalance. And I think it's a very good DCOS. But because it had Google behind it, pushing it, it became the container orchestration framework that everyone's using. I think it's not the right abstraction level, and people are scrabbling to fill all of these different use cases with that hammer, like Xavier said.
Mm-hmm.
So we end up with these Frankensteins everywhere. Every company has a different Frankenstein. You talk to any Kubernetes engineer, or any DevOps engineer who's using Kubernetes at any company, and they have set it up slightly different. It's madness. It's absolute madness at the moment.
So can you guys list a few alternatives to Kubernetes? I know we're talking about Kubernetes, but it's always good to understand what else could you use. You mentioned Cloud Run and App Runner. That's the AWS version of Cloud Run, which is in GCP. You can just run microcontainers in the sense that you can run Lambdas as well, right, in AWS, or function as a service, because that completely removes the need for running your own
Well, we haven't
infrastructure, right?
talked about Knative either, which is running functions as a service on Kubernetes.
Okay, so you can do that as well.
I had someone at the company I'm working for reach out to me the other day. Oh, can we do Knative? I just use Lambdas, please.
No, but I really think it's a good point you're making there, that we probably are in the wrong abstraction level for companies. It's a bit like if someone had deployed a half working, very simple operating system, and companies were implementing drivers and disk controllers and schedulers themselves, right? And then you would be familiar with probably the POSIX standard, but you would never know exactly how from company to company would be very different. So that's probably one. But I'm not sure that the market has become so competitive that I don't trust it to consolidate into a standard solution. I think the incentive for the companies is to tie you down to their system so you cannot move easily to another system. And that's happening more and more.
So this is supposed to be a standard. So in theory, if I create my container and my description, I could run it on Google, I could run it on AWS or my own data center. Is this a reality? Like, can I define my application once and then run wherever?
No, that was the initial promise. But the problem when you have all these options for personalization, so to speak, is that you would have to stumble upon two Kubernetes clusters that have configured the same exact add-ons. Because we don't even talk about it, but other very, very basic components of a Kubernetes cluster today is both external DNS, which is what allows you to export your DNS records that only work inside the cluster to a public DNS in an automatic way. And then, of course, Cert Manager, which automatically generates SSL certificates and manage their renewal. So, for example, imagine that you are deploying in a cluster that uses external DNS, and you know that if you set this label, this and that, automatically a DNS record will be created. And then you go to another place that it's not using that, or is using another variant, or is using simply another convention, and the label is not called record, it's called records or whatever. Your manifest is not going to work there, or it's going to partially work. And not to speak of all the very customizations that all the cloud providers have that are much more complex than this. So that's also a promise that never got accomplished. I don't know what.
So it's a great technology, but we managed to make it so complex that you always have to be conscious if you should use it or not, or how you should use it.
I mean, I feel like these days, if you're running containers, everyone kind of expects you to be doing Kubernetes, which a lot of the times is not the right choice, because it's, like you said, it's very expensive startup. You need a lot of knowledge or expertise to run it properly. It's very easy to overcomplicate. Yeah. But let's touch on one more thing. Where do you see the future of Kubernetes, though? From your perspective, what's the future? Because I think you mentioned it a little bit, but give us your predictions.
Well, I mean, there is this clear trend now where providers are incorporating more and more of these, let's call it satellite services that everyone is using. That I guess it's a good way if they do it in a transparent way. Like, for example, AWS announced, okay, you have hosted Argo. I think that's the right way. Everyone knows what Argo is, and you just need to use it as you would use the one that you install yourself. It's not that good when companies start making app names and they call it something else and even modify it slightly. That's, for example, Microsoft is very known to do that, because then again, you create these silos, and as a developer as well, you have to learn different clouds and so on. So that I think definitely will be a trend. And maybe in the future, like using Kubernetes will be a bit like using either Windows or Mac OS. You won't care. Like it will be slightly different, but in the end, same abstractions, and it will work so well that you wouldn't really be worried about it. As Krisztian was saying, as a developer, you won't care if you're using Carpenter, what you're using.
I want to not having to care.
Yeah.
Where it's running.
Hopefully it's there where we are getting, but then that is going to create the void of, okay, yeah, if I use one of these providers, it's going to be like this, but what's going to be if I am running my own service? Because I think most companies don't run their own servers, and that's the right decision, but there is still a market, if you will, or a space where people want to run their own things, either for regulatory purposes or simply because you are a small project. And I recently had this dilemma. I just needed what we used to call a LAMP stack. I had a website with a database, need to run it somewhere. And it's so little used that it's not even worth the $4 or $5 monthly that you have to pay minimum somewhere to have a server. And I ended up hosting it in a small Nook, if you know what that is, a small computer at home, like you used to do. But then the next dilemma was, okay, I want to run it as a container, as we said, because containers give you all this isolation and all these dependency-free problems. But it's like, how do you then run one container in one server? And that got me into a rabbit hole. I ended up using Docker Compose, and then I actually discovered, well, for me new, and I guess everyone knows about this, Caddy. It's kind of like a reverse proxy that handles Let's Encrypt automatically. So you don't need to have, for example, Nginx and Set Manager. You just need one process that takes care of everything. And I put those, but I don't really like that as either, because it seems a downgrade, because Docker Compose in its default form doesn't handle very well the restarts or the health probes and anything like that. There should be, I guess, systemd is the in between, but no one knows what systemd is anymore.
Sort of like K3S or something. Is it K3?
Yes, yeah, exactly. That's another thing that we could talk about for hours. The micro frameworks like K3's, Kind, and Minikube.
Yeah.
I think was the first.
What are these? I'm not familiar with this. What can these do for us?
So these ones use different tricks, but essentially what you get is a small Kubernetes cluster running on your laptop. So if you are developing something for Kubernetes, then you can test it and you can deploy it there and so on. So in that sense, they're very useful because they allows you, like, you literally run one command and then you get a control plane and you get to one or two hosts and you can use kubectl with them as it was a real cluster.
So you can use this to test deployment, tooling, or something.
Exactly. And for that purpose, fine. I would never host an application that I expect to be responsible for in one of those, because for the trick part that I mentioned in the beginning, they use so many abstraction layers to trick your laptop into thinking that is a cluster with several hosts running somewhere else in the network, which is like several like network namespaces, virtual machines and whatnot, that even if your purpose was, I want to run this process on this machine, it's like with several abstraction layers that make it very difficult to debug if you have any problems. But yeah, those are actually very good.
So
solutions.
Kubernetes light solutions for local development and others.
Yeah. And of course, they're getting abused by some products to make like production grade deployments on those things that were thought of just developer testing.
So let's do a quick summary. Kubernetes is very flexible. It's the industry standard for running containers, and it's kind of like the industry standard for abstracting running workloads on most days nowadays. It's very complicated to run yourself on DC. It's possible on on-prem stuff. Even if you're running it on the cloud, and it's very easy to set up a Kubernetes cluster itself, it's quite complicated to set up all of the additional tooling that most teams expect these days. So if you're thinking about Kubernetes, or if someone's asked you for Kubernetes, you probably need to get someone in who understands what they're doing. Otherwise, they can make some pretty big mistakes early on. That would be my summary. So it's a very interesting space, but it's standard engineering. Engineers going to engineer, and we end up with these massive fun things. When you're doing Kubernetes, try and avoid pushing too much software complexity down to the infrastructure. Try and keep it simple as possible. Yeah, I think that's a good summary. Did I miss anything?
I would add, if someone is thinking if Kubernetes is worth learning or not, someone that maybe it's starting in the industry, I think that's the one thing that it is good at, generating work for companies, because it's never-ending complexity. So I think it definitely is worth learning, either as a user or as a team.
So it's a very good skill to have if you want a job, or if you're already working in the industry and you want to somewhat future-proof yourself. It's not quite up there with machine learning and AI, but it's up there. So it's worthwhile. I want to say thank you, Xavi, for joining us. It's been super interesting.
Yeah. Thank you.
We'll hopefully have you back on at some point for some other topics, deep dive into networking, designing layer 3 networks and stuff, because we did that before. But thank you for joining.
Thank you, Xavi.
Thank you for having me. It's been very nice, very fun.
Nice. Thank you, Krisztian, as always. And then for those of you who haven't liked and subscribed, please like and subscribe if you're watching on YouTube. You can find us on YouTube at Tech League Podcast, on Spotify at Tech League, on Apple Podcasts at Tech League. And if you want to get in touch with us, you can through techleaguepodcast@gmail.com.
Thank you.
Nice.
Puss.
Thank you. Puss.
Thank you for listening to the Tech League podcast.